This is section 9.10. 9.10 is our last alkyne specific section and our last section of exam 3. So what makes alkylation of terminal alkynes special, and why does it get its own section? Well, if you'll remember from our chapter on acid-base chemistry, that alkynes have a low pKa for carbon-hydrogen bonds due to the sp orbital. And because of this low pKa, we can deprotonate it with, it's a strong base, but not the strongest base, sodium amide. And if you deprotonate the alkyne with sodium amide, you end up getting the anion that you can then treat with some alkyl halide in a substitution reaction to make the internal alkyne product. You can do this also with acetylene, which is just C2H2, by doing the alkylation twice. So first, you deprotonate with sodium amide, and you alkylate with some alkyl halide to alkylate one side of the acetylene. Then you perform the reaction again with a different alkyl halide to make some internal alkene, as you see here. But one thing to note about alkylation of terminal alkynes is they're not that nucleophilic. So if you have a primary substrate, then the reaction will probably work fairly well. But if it's not a primary substrate, the alkyne is not nucleophilic enough to really do the substitution reaction well. So it will just act as a base instead, and you will end up getting the elimination product instead. So just to be totally clear here, you can do alkylations of alkynes by applying sodium amide and then some alkyl halide to give the substitution reaction, as long as it's a primary substrate. If it's not a primary substrate, then it will be an elimination reaction instead.